Okay. So the very first question, it says, what is the theoretical yield of phosphorus triiodide when 4.5 grams of phosphorus is combined with 45 grams of iodine? The compound is made by the direct combination of the elements. Okay, so the first thing that we need to do is to do what?
Get the balanced equation.
Balanced chemical equation. Okay, so they told us that it's made by the balancing of those, by the combination of the elements. So we know we have phosphorus and we have iodine. So what is the chemical formula for phosphorus
P4,
and iodide?
I2.
And we're going to be making phosphorus triiodide. Okay. So then what are we going to do now?
Balance it.
That's right, we're going to balance it. Okay, so we have on our reactant side, we have how many iodides or iodine?
2,
Product side,
3,
phosphorus.
on the reactant 4 and 1 on the product.
Okay. So what do I need to do to balance it?
Multiply the PI3 by 4.
Okay, so then that'll give me 12 iodine and 4 phosphorus.
6 on the I.
Okay, so now that we've got it balanced, what are we going to do next?
Find out how much phosphorus triiodide you can make for each of those masses of 4.50 grams of phosphorus and 45 grams of iodine.
Okay, that is correct.
So you can use like 4.50 grams of phosphorus and then multiply against the molar mass to find the moles for that one.
Okay, so we got 4.5 grams. We're going to multiply or divide by the molar mass.
We multiply against the molar mass. So we put the grams on the bottom and then
Okay.
1 mole on top.
Okay. Okay, so then we have P4. So phosphorus is, let me pull up my periodic table since I don't have it handy. Okay, so phosphorus is 31 roughly. So 31 times 4. Let's see.
124.
Okay, so we have 124. That's grams per 1 mole. Okay, so then that's going to give us our moles of phosphorus. And so if we continue, I'm going to go ahead and erase our balancing part here. Okay. And then going to go ahead and get the iodine for us. So iodine, put it on the side over here. It's what? 126.9. So say 127. roughly. Okay, so how am I going to get to moles of the triiodide?
Using the multimole ratio.
I'm using the multiple ratio. So for every 1 mole of P4, we have 4 moles of PI3. Okay. So that looks horrible. Okay, so then we need to figure out how much PI3 weighs. So we know phosphorus was 31. And then we have 3 times, so plus 3 times 127. What do you guys got? So I get 412, 412 grams. PI3. For every 1 mole. Of PI3.
Theoretical yield is ideal yield, right?
What was that?
Theoretical yield is ideal yield.
That is correct.
Okay.
Get 59.8 grams. Okay. And so is that what we're going to settle with, or do we need to do something else?
Need to do something else.
Okay. So since I know that I have two different reactants that are given to us, I'm going to have to do the same thing with the iodide, right? So then we'll have our 45.0 grams of I2. So for every 1 mole of I2, that's going to be, is that 254?
Yes.
So what are we going to use to get to our moles of triiodide?
The
The
molar
molar ratio?
ratio.
Okay.
Oh, wait, Professor. It's supposed to be I2 for the bottom.
Oh, thank you. So then that would be 6. Thank you. I just was going on autopilot there.
It's okay. It's because I had it written down. I looked up at the page at the screen. I was like, hold on a minute. I didn't get one.
And then,
And this is the same for the top part, the 412G.
okay.
So once we find that, we add it with the phosphorus triiodide, right? And then that's what we get.
Yeah, so we figure out which one is going to give us the lowest quantity, right?
Oh,
So that's going to be the correct answer. Because remember, one of them is limiting, one of them is in excess. So we're really trying to figure out which one is limiting and which one is in excess. So. Okay, so we have 45 times 4 times 412 divided by.
so it's just whichever one has like the least amount.
That's right.
Okay.
So because remember when we talked about the bread, like the grilled cheese sandwiches?
Yeah.
Because you're going to run out of one of them before the other. And as soon as you run out, you can't make anything else, right?
Yeah.
Okay. So the correct answer would be A. Let me erase this. Be the first one. Okay. I'll let you guys get that down. Are there any questions? Okay. You guys ready to move on?
So theoretical yield is the lowest one.
So no, theoretical yield is what you've calculated. Actual yield is what you actually get. And so here, because since we have, anytime that you have two values that you have for for grams or for moles, that basically means that one of them is going to be acting in excess and one of them is going to be limiting. And so what we want to do is figure out how much we can make, right? And that before you run out of it, right? And so that's always going to be your lower number. Like if you figure out your product, whatever your lower number is, that's how much you can make. Because the other one is in excess. The one of them is limiting. You're going to use it all up. Once it's all gone, you can't make anything else. Does that make sense?
Yes.
Okay. Okay, propane is burned as a fuel in heating homes. Write the balanced chemical equation for the reaction for this reaction. What is the coefficient for CO2?
So this is an oxidation chemical reaction or burning.
It's a burning or an oxidation or a combustion reaction. So that means what?
So you
C3H3 plus O2 yielding CO2 plus H2O.
Okay. Do you guys agree with him?
Yeah. I was
Okay.
about to say that, but he cut me off, but it's cool. It's cool, it's cool.
The fastest yapper in the West.
Is it CO2 It's H2O. Okay. So let's go ahead and balance it. Oops. So on my reactant side, how many carbons do I have?
3,
Product.
1,
Reactant side, how many hydrogens?
8,
Uh,
2,
reactant side, how many oxygens?
2,
And product
and then
side,
3.
okay, do you guys all agree? Is it balanced?
No.
Okay, so what do I need to do to balance it?
We can put a 3 in front of the CO2.
Okay, so put a 3 in front of the CO2. Okay, so then that gives me 3 carbons.
And 7 oxygen.
Okay, and 7 oxygen because we have 3 times 2, which would be 6, plus the 1 that's over here, right? Okay, what about the hydrogens?
We can put a 4 in front of the H2O.
So then that would give me 6 plus 4.
That's 10. And our reactant for oxygen, we can just put a 5 as a coefficient in front of oxygen.
Okay. Okay, so we're balanced. So then the question asks, what is the coefficient for CO2?
It's 3.
Okay. Okay. Okay, for this next one, Mark, I want you to let somebody else answer. Okay?
I don't think so. Okay, I'll be quiet.
I will mute you if it's necessary, so don't push my buttons. Okay? So number 3, it says, in the net ionic equation for the following, what is the spectators? What are the spectators? The equation is ammonium nitrate aqueous plus calcium chloride aqueous. I mean, not calcium, phosphorus chloride aqueous yields phosphorus nitrate aqueous and ammonium chloride aqueous. So who's going to help me out with this one?
Besides me.
Yes, besides Mark.
Well, I think the first thing you have to do is balance it, right?
Okay.
Well, hold on a second. Since everything is aqueous,
Oh
there's
yeah,
really
yeah,
not
yeah,
a chemical
yeah, yeah.
reaction.
Okay.
So we can just say
There's no
everything is
soluble
spectator.
or precipitant or whatever.
Okay. Well, you said there's no spectator or they're all spectators?
They're all spectators.
They're all spectators. That is correct. So since everything is aqueous, they're all spectators.
Yeah, because there's no precipitant. Yeah.
That's right. Okay. So the answer would be, okay. Okay. Let's see, who else is there? So who's going to help me out with this one?
I can.
We're going to table you, Mark. One more. Give me one more, and then you can help me out with the next one. So, Jinxie, are you feeling up to it?
Well, to start it off, we can just write the ammonium ion and the sulfate ion.
Okay, so we know we have the ammonium ion. So what is the chemical formula for the ammonium ion?
NH4 plus.
NH4 plus. And the sulfate,
SO4 2 minus.
okay? So then what do we need to do for this to be a compound?
We gotta balance the charges.
We've got to balance the charges. So then how many ammoniums will we need?
2.
And then that means we only need that one sulfate.
Yes.
Okay. Struggling with my pen here. Okay. Okay, so then how many nitrogens are we going to have then?
2.
We're going to have 2 nitrogens. So we can get rid of these 2 because we know that they're wrong. Okay. And the last one. Okay. So then how many hydrogens are we going to have?
8.
8. Okay. And then, so that means we can get rid of this guy. So the correct answer. Okay. Okay, you guys ready for the next one? Ready, Mark?
Yes.
Okay. Help me out with it.
Since there's 0.188 moles of sodium, we have to use Avogadro's constant, which is 1 mole of Na over 6.022 molecule of Na.
Okay. So you said 1 mole on the bottom. And then we're going to use Avogadro's constant. You said it's 6.022 times what?
10 to the 23.
And
And that should be 1.13 times 10 to the power 23 molecules for sodium.
okay. You guys agree with him?
I trust Mark.
You trust
No, you
Mark?
don't. No, you don't.
Okay. Okay, you guys ready for the next one?
Yes.
Cadell, are you ready for the next one?
Yeah.
Okay. Okay, it says a coolant widely used in the automobile engines is 38.7% carbon, 9.7% hydrogen, 51.6% oxygen. Calculate the empirical formula for the compound.
Do I get to chime in?
Let's give somebody a chance first, and then you may be able to help out.
So every 2 I can chime in?
Yeah, we'll do that. That'll work.
So wouldn't you have to like change those percentages into moles first?
Okay. So we need to change those percentages in moles. So are we going to assume that they're moles, or are we going to assume that they're grams?
Yeah, because you could basically translate percentages into grams, right? So you could
Okay.
you
Yeah,
just
'cause we're making the assumption that it's our molar mass, right?
yeah, because it's by 100.
Or a mass percentage, not
Yeah.
our mass, our mass percentage. Okay, so we assume that this is 38.7.
Grams of carbon.
Okay. And then we have
Then I think molar
9.6.
mass.
All right, let me write these down first so that I won't forget what I'm
Okay,
doing.
okay.
Old age, bear with me. Okay, so now you're going to tell me about the atomic mass of carbon, or its molar mass. Did I lose you guys? Are you guys here?
So for every 1 mole, there's 12 carbon.
12 grams of carbon.
Yeah, 12 grams of carbon. Yeah.
For every 1 mole of carbon, there's 12 grams of carbon, approximately. And we get that from the periodic table, right?
Yes.
Okay. So
So then, wait, let me calculate that. Let's see.
Is it 3?
Yeah, it's 3. If you just round it.
well, we want to be careful about
Oh, wait,
just
no, wait. Yeah, it's
Not yet.
3.22. No, 3.23.
Okay, are you sure? Let's see, 38.
Wait, did I do that right? Let's see.
divided by- I might have done it wrong. Yeah, 3.22. Okay. 225, right?
Yeah, 225.
Okay. So but you're right, it would be 2 if we're paying attention to sig figs.
Yeah.
Okay, moles. Okay, and then hydrogen. What is the molar mass of hydrogen, or the atomic mass of hydrogen?
It's 1.
1. So 1 gram of H. (9.7 moles).
Does it matter if we round like the mass?
It depends, because you want to be careful with that sometimes.
Mhm.
So if it's really close, like for instance, we have carbon, which is 12.00, I think it's 008 or 007 or something like that.
0.11 right
Oh,
here.
0.11. Okay, so 12.011, right? So that would be okay, right? Because that 0 is in front, so it's going to be really close to 12. But let's say you had chlorine, which is it 30.45?
35.45. Yeah.
35.45. Okay. So in that case, then we don't want to do that because it's so close, like it's in that middle part. So you
Yeah.
want to take that in consideration.
Yeah, you wouldn't want to just round it to 35, huh?
That's right. Or 36, so.
Yeah.
Yeah. Okay, so for oxygen, what is the atomic mass of oxygen?
16.
16. So oxygen is a good example because it's 15.9999, so
Yeah, that 0.1 doesn't really matter.
yeah. And particularly when you're doing empirical formulas. I've got burnt a couple of times, getting anxious with my rounding. Okay, so then what do we do next?
Wouldn't we round everything by like a whole number and then divide it by the
Divide.
smallest?
What was that? Somebody said it? I heard an I. See.
Divide
Yeah,
by
divide
the
it by the smallest.
Divided by the smallest. Okay. So we're going to divide it by the smallest. So 3.22 is the smallest. Let's do it in a different color. Okay, so that's going to be 1C. Check my math. 3 H's and 1 O. Okay, so then our chemical compound or our empirical number is going to be C. Our empirical formula is going to be C3O. Okay, do you guys agree?
Yes.
Jackie, do you agree with them? I take that as a yes. Strong yes. Okay. Oh. Okay. Okay, let's do the next one. Which of the following compounds is the best example of a hydrocarbon?
Do I pass on this one too?
You can answer this one.
It's 3 because it's only CH because hydrocarbon is only carbon and hydrogen.
Okay, that is correct. Okay, so that means you have to give up the next one.
Now, I'm just wondering
That's
about
fine.
these hydrocarbons.
Yes.
It's not
So-
just hydrocarbons that can go through combustion, right? Because I see sometimes they have oxygen in there.
Yes. So it's not just hydrocarbons that can go through combustions. Anything that's organic can, in theory, go through combustion.
Okay.
Okay. So long as that carbon is available and you have your carbon and your hydrogen, usually can get combustion.
But those aren't considered hydrocarbons.
No, they're not considered hydrocarbons because hydrocarbons are just hydrogen and carbons,
Okay.
but they're considered to be organic.
All right. Thank you.
Okay. So the next question says, in the complete combustion, hey, perfect question. In the complete combustion of C3H8O3, how many moles of carbon dioxides are produced when 23.0 grams of C3H8O3 burns? So it's the first thing that I want to do.
Balance the equation.
Okay, so we need to balance the equation. So we know we have C3H8O3. And we know since it's a combustion reaction, what also has to be present?
Oxygen.
Okay. And the product is going to be?
CO2 and H2O. Are the products of a combustion reaction always just CO2 and water?
Yes.
Okay.
There are certain circumstances where you'll get byproducts, but the majority of it is going to be carbon dioxide and water.
Okay.
Yeah, so there's an occasion where you get carbon monoxide, and occasionally you'll get just carbon when you burn it so hot that it breaks up the carbon and the oxygen. But in our cases, we're not doing that. We're doing controlled burns. Okay? So then let's go ahead and balance it. Okay, how many carbons do we have on the reactant side?
3.
Product side,
Two.
1.
how many hydrogens on the reactant side?
8.
Product side,
2.
how many oxygens on the reactant side?
5.
Product side,
3.
okay? So what do we need to do? To balance out the carbons.
Well, this one's a kind of annoying one, but we can start by multiplying CO2 by 3.
Okay. It is an annoying one.
Yeah.
So then that would give us a total of 7 oxygens. Okay. And then what about the hydrogens?
We can multiply water by 4.
Okay. So that would give me 10. Oxygens.
Two on the oxygen.
That'd be enough?
No, so you kind of get stuck here
Mm-hmm.
because you can't really multiply that coefficient by a whole number.
Mm-hmm. Okay, so in this case, what we're gonna do is we're gonna subtract the 3 that comes from this compound, since we managed to get everything else balanced, right? So if we get the 3 that comes from that, so 10 minus 3. And that's gonna give us 7, right?
Can I blurt it now?
What was that?
Can I blurt it now?
Not yet, wait. So then this guy is gonna be 7/2. And since we're looking at things on the molecular scale, we know that we can't get a half of a molecule. So then we're going to multiply everything by 2, right? Is that right, Mark?
Yeah, I was gonna yell double or nothing.
Okay.
Well,
So
actually,
then,
in this case, we are looking at moles, so technically we could.
yeah, I guess we could leave it as a half. That's true. But I want you guys getting a habit just in case, right? So 2, and then we have 7. Then we have 6. So, but yes, you're right. Since we are looking at moles, we could get away with it. And we have 4. Oops. As I erase everything. Okay. Oops, 4. Oops, 8. Okay. 16. So now we have 16 hydrogens. We have 6 carbons, 16 hydrogens, and we have 6 plus 14, so that's 20. So that's 12 plus 8, so that'd be 20 oxygens. Okay, so now we got it balanced. Next part. So we have 23.0 grams of our compound. So what do we need to do next?
Molar mass.
Molar mass. So we need to calculate the molar mass of this compound. So we have 3 carbons, 8 hydrogens, and 3 oxygens. We know carbon, so 3 carbon weighs 12. So 3 times 12 equals 36. We have 8 hydrogens. Hydrogen weighs 1. And we have 3 oxygens. And oxygen weighs 16. So that's 48. So So 92 grams per mole. Is that true? Or am I just making?
Yes.
Okay, so we're going to divide it by the mass. And then what else do we need to do?
Use the molar ratio.
Okay, so we need that molar ratio. So for every 2 moles of the C3H8, O3, we get 6 moles of CO2. What do you guys get?
– 0.750 moles of CO2.
Okay, so not too bad.
No. Do I set out for the next one too, or no?
You got to sit out one more and then you can do the one after that. Okay, so somebody help me out with number 9. Somebody other than Benjamin and Mark.
It's the first one.
It's the first one?
Yeah.
Okay, yes. So we know that when we talk about percent yield, it's going to be the actual over the ideal, or we call it the theoretical, and we're going to multiply it times 100. That is correct. Okay, so we can do a group effort on number 10. So we can all work together on that. Okay, number 10. It says calculate the mass of sodium oxide that can be produced by the reaction of 4.00 grams of sodium and 2.00 grams of oxygen. In the reaction, 4 sodium plus O2 yields 2 sodium oxide. Okay, so first thing that we should do. Well, they were nice enough to give us the chemical equation.
Yeah, the equation looks it looks balanced.
Okay. Okay, so we have a balanced chemical equation already. So then,
Is that balanced? Oh yeah, it's balanced.
Looks like it.
Yeah.
yeah, but we should always make sure. That's good that you guys are all looking at that. Okay. So we got a balanced chemical equation. So then what are we going to do?
We're gonna take the 4 grams of sodium and multiply it by the molar mass.
Okay. Okay, so what is the molar mass of sodium?
Let me see. 22.990. Can we get away with 23?
We can get away with 23. So it's 23 grams of sodium per 1 mole. Okay, so then what's
For
next?
every 4 moles of Na, we have 2 moles of Na2O.
Okay, so for every 4 moles of Na, we have 2 moles of Na2O. And I forgot to put my moles down there. Oops.
And then you go back to molar mass to find the grams.
Okay. That should be moles here. Sorry. So we need to go to molar mass. So we need to find the molar mass of sodium oxide. So we know that Na, there's 2 of them. And
That's
so,
46.
okay, so 46. And then we have oxygen, there's 1 of them. So 16. So that's a total of 62.
62.
Excuse me, the lights went out on me. Okay. And that's grams per mole. So for every 1 mole, we have 62 grams of Na2O. Okay. You guys end up with
5.39 grams of Na2O.
okay. And so what's next?
Now we do the oxygen. So 2.00 grams of O.
Of O2.
Yeah, O2. Yeah, because it's diatomic.
Okay, so then that's 32 grams O2 for 1 mole. Mole ratio. For every 1 mole of O2, we have 2 moles sodium oxide. And then we can use that same value that we have up here. So for every 1 mole of sodium oxide, that is going to weigh 62 grams. Okay, so my correct answer. And they're nice. They didn't even put the second possibility up there. Okay. Number 11. Number 11 is just like what we just did with number 10. It says, in the reaction, 2 silver iodide plus mercury 2 iodide yields silver mercury 2 iodide. .00 grams of silver iodide and 3.50 grams of mercury 2 iodide were used. What is the limiting reagent? Okay, so what are we gonna do? Start with that 2.00 grams. What's going on? Are you guys there? Or did I lose you?
I was sitting out for this one.
Okay. Okay, so we have silver iodide. So we know that iodide, if I remember correctly, was 127. Let's confirm.
Yeah, it's 127.
Okay, and then silver is 107.87, so approximately 128. Oh crap. Okay, so I mean not 128, 108. So AG it's gonna be 107.87. And then And while we're over there, we're gonna grab mercury as well. Go back and grab mercury. So that we can make everything. Okay, so mercury is 200.59.
Wouldn't silver iodine be the limiting reactant since it has the least amount of grams?
Nope, you can't rely on the grams. You gotta look at the moles.
Oh, okay. Is moles like more accurate than grams?
Well, because everything is based upon moles. We're talking about quantity. When we're doing a chemical reaction, we're not necessarily talking about grams, because when we talk about two here, we're talking about the quantity that we have. And so you always want to base it on quantity, not mass.
Okay.
Good question, though. Okay, so then what is that? It's 127 plus 107. So what's that? 234.87. That's grams of Ag. I. That's 1 mole. Okay, and what's the mole to mole ratio of Ag to Ag2H? Mole mole ratio? Anyone?
2 to 1.
2 to 1. So we don't have to find the grams. All we have to do is find the moles in this case, because they just want to know which one it is. So then we'll just go ahead and solve that. Ag. To H. G. I4. Okay. And so we'll go ahead and use that 3.50 down here. Okay, so what's that? Okay, so we have 2 iodides. So that'll be what, 254 for I2. And then we're adding the Hg, which is the 200.58. So what, 454.8. I mean, 58. So we're gonna go ahead and put that down here. Okay, so what is the mole to mole ratio of the mercury 2 iodide to the silver mercury 2 iodide? Mole to mole ratio,
It's 1-to-1.
it's 1-to-1. Okay, so based upon the number,
So limiting reactant is AGI.
Okay.
Just a question. If
Yep.
there were two products, would we just
Yes.
have to focus on one of the products and that's it?
So there would never be two products, right?
Okay.
Doesn't that make sense? Because you're
Maybe
putting
like
the
a
react.
double displacement, something like that.
No, because you still, you could never start off with two quantities for two products, right? Because you need the reactants to make the products. Does that make
Isn't
sense?
this like a
Oh, right,
synthesis
yeah.
reaction?
What was that?
Isn't this like a synthesis reaction?
Yeah, this is a
Combination?
synthesis reaction. Yeah.
Okay.
Wait, why is silver iodide the limiting reactant again?
Because it's the lower value, produce the lower amount of the silver mercury 2 iodide. So it's 0.0046, and this guy is 0.00770.
So the one that gets used up more is the limiting reactant.
That's right. Because you're gonna run out of it first, right?
Yeah, I'm just trying to like wrap that around my head.
Yeah. So you always have to think of it. The thing that you're gonna run out first is gonna be limiting, right? Because after you don't have any more of it, can you make any more?
No.
You have to go to the store and buy some more, so. Okay. Ugh. How's your brains going so far? Okay. Doing
Better.
well?
I got 8 hours of sleep today.
I'm jealous.
It's all coming back.
It's all coming
Don't
back.
worry.
Yeah.
Today is
It was
gonna
just-
be
it
a
was-
4 hour sleep.
Yeah, it was just all buried in my mind, so
Okay.
I'm just
Okay.
digging it out again.
Okay. Okay, number 12. When coasting on a bicycle on a level street, the bicycle will eventually come to a stop. Which of the following best explains Which of the following is the best explanation for this apparent violation of the conservation of energy? A, the kinetic energy is converted into equal amounts of other forms of energy. B, the rubber in the tires is converted into energy. C, if there is no air resistance, the bicycle will continue moving indefinitely. D, the street must actually be slightly angled uphill. Or E, this is not a chemical reaction, so it doesn't obey the law of conservation of energy. Benjamin, I definitely expect you to answer this one.
Yeah, I believe it's the first option.
That is correct.
So the kinetic energy is becoming, well, through friction, it's
That's
becoming
right.
heat.
That's right. Yep. Yep. So we know it's that guy. Okay. So what is the state of matter in the illustration in the illustrated below? Should be the illustration below.
Looks like a liquid.
Okay. Do you guys agree? That would be correct.
Yeah, I agree.
So are we supposed to interpret this picture based on the distance between the atoms?
That's right.
I thought it was like
Okay.
more of the looks because like everything looks shaken up a bit. It's like you grab a jar of water and you see the bubbles moving in it.
Couldn't it also be a solid, though?
No,
Let's be a little
solid,
closer and
particularly-
more in a form.
Even closer?
yes, they're gonna be
Solid would
close.
mean there's like nothing like in between it. Everything would just be like close together.
Okay, yes, but if it's water, it's gonna form a structure. It's gonna form like a nice little ring structure. So because of the
Hydrogen bonds?
the hydrogen bonds between the two. So it's gonna be really organized. So you're gonna see organization in there. So
Yep.
typically solids are either all packed together or they're gonna be organized in nice crystal structures. Does that make sense? You'll have order associated with it.
Yeah.
Number 14. It says, which of the following correctly matches each sample with its classification as macroscopic, microscopic, or particulate? Okay, your first choice, protein molecule, cat hair, plant cell. Your second choice, protein molecule, plant cell, cat hair. Your third choice, plant cell, cat hair, protein molecule. Your fourth choice, cat hair, plant cell, protein molecule. Your fifth choice, cat hair, protein molecule, plant cell. What do you guys think? Macro, what does macro mean?
You can see it with your eyes, basically. It's
You can
visible
see
to
it
the
with your
eye.
eyes. Okay, so you can see it with your eyes. Okay, then micro means
You can see it through a microscope.
you can see it through a microscope. And then particulate,
Like an elementary particle.
particle. Okay. Okay, so which one would best fit? So the order is macro, micro, and then particulate.
Let's say the fourth one, maybe.
You said the fourth one. Let's see. So you said cat hair, plant cell, and protein. That is correct. Yeah. Okay. Because we know that proteins are found in cells. So proteins have to be smaller than our cells. Okay, number 15. Okay, first off, what state would this these compounds be in? I mean, this compound be in, looking at the image.
Gas.
A gas, that's right. Okay, so it says, considering the following image, which of the following most accurately describes the change represented in the image? A chemical change which follows the conservation of mass. B, a physical change which does not follow the conservation of mass. C, a physical change which follows the conservation of mass. D, a chemical change which does not follow the conservation of mass.
Well, it's definitely a chemical change because the bonds are changing.
Okay. It's good. So we can get rid of these. Okay. So then how would I determine whether it's following the conservation of mass?
Gotta count them up.
Yes, we're going to count them up. And so we have the big ones that are here in the middle. So we count these. That's 1, 2, 3, 4, 5, 6, 7, 8. So we should have 8 big ones, right? And we have 1, 2, 3, 4, 5, 6. So that means it doesn't follow. Probably means that we lost one along the way. So, right?
Could it be radiation? That they
Radiation.
broke off?
I guess it could. It broke off to the smaller component. That's a possibility. Yeah. It decayed. You had a
Yeah.
decay of into the little guys.
Alpha
Possibly.
decay? Yeah.
Yeah. Possible. Okay, so we know it's the last one though. Okay. The next one, number 16. It says, distance and time are directly proportional for an object moving at constant speeds. What is the value of the proportionality constant if a car travels, for a car that travels 133 miles in 2.5 hours?
Would you just divide the distance by the time?
Okay,
So 133 divided by 2.5?
okay,
I think so.
yep. And so that should be the value of our constant, right?
Yeah, approximately 53
Mm-hmm.
miles per hour.
Yep. Okay, good. So the way that you would look at this is that you'd have your distance, and it's going to be directly proportional to time. So, and then you'd have your constant over here. So then you'd say your distance divided by your time
Is that like a conversion factor?
yeah,
Okay.
going to equal your constant. There you go. Because as soon as you put that constant, that means that you can use the equal sign. Yep. So it's like a conversion factor.
And you can also divide time by the distance, right? That would
That's
be
true.
also valid.
That technically, yes, because then you could put your constant on the
Yeah.
other side, but it will be a different type of constant.
Just not as useful.
Yes, that's right. Or what we're familiar with. Okay, number 17. The melting point of iron is 1,553.0 Celsius. What is the Fahrenheit equivalent of this temperature? So what is that equation that we're going to use to convert?
Wouldn't you just subtract it with 273?
Nope.
No,
this is,
that's
that's-
Kelvins.
That's Kelvin,
That's
yeah.
kelvins, that's right. So Fahrenheit is going to be T Fahrenheit. Fix that. It's going to equal 1.8 times, you guys remember? It's on your packet.
9/5.
Yeah, which is 1.8. Times what?
times Celsius plus 32.
Okay. Okay. So then
That should be 2,795 Fahrenheit.
okay. Do you guys agree? Okay. Let's move forward. Number 18, it says the meter stick in the image is being used to measure the length of a piece of wood. How many significant figures should be used to express the measured length?
This one kind of trips me up, but I believe it's just 2 significant digits.
Okay. So if we take a look at our little piece of wood, so we would have the ones that we are sure about. We know we would have the 10 spot, and then we'd also be familiar with the 1 spot, right? So that would be what, 4? And then we would know that there's the other one, which we don't quite know, we're not sure about, right? So we would have 2 significant figures. That is correct.
So we can just say this is 34.
Yeah, we could say a 34 for sure. Yeah.
Yeah.
34 point what? We're not sure. That's the crappy thing about motion detection. If you don't move enough, lights go out on you. Okay, you ready for the next one? Let's see. What is the volume of 22 grams of gold, which has a density of 19.3 grams per cubic centimeter?
I'll get it started. We could start with the formula density equals volume over mass.
Okay. So density equals, you mean mass over volume?
Yeah, mass over volume.
Okay. Okay. And so we're
Remember by the
given,
DMV.
that's right. And we're
I
given
hate that
the density,
line.
or given our density. And we're given our mass. So we have to calculate our volume. Okay, so we want to get volume by itself. So we multiply both sides by volume. And then we divide both sides by the density. So you'll get 22 grams divided by the density, which is 19.3 grams per cubic centimeter. And so that's just going to give us cubic centimeters. Is that 1.1? Okay, you guys agree or disagree?
Yeah, I agree. But instead of like memorizing the equation, sometimes you just gotta play around with the units that you're given. So in this
That's
case, you
right.
got grams and then something that's grams and centimeters cubed. So you can just get the grams to cancel out.
That's true. Yep, that's one of the strong parts. If you're familiar with the units, that's the best way to do it. And it's also a great way of confirming your results rather than memorizing an equation. Okay, you guys ready for the next one? 20. Says, which of the following, oh, I'm sorry. Considering the following generic picture of an atom, which of the following is correct about the regions labeled 1 and 2? A, region 2 is populated by electrons and neutrons. B, region 2 is populated by electrons and protons. C, region 2 is populated by protons and neutrons. D, region 1 is populated by protons and electrons. E, region 1 is populated only by electrons and region 2 only by protons.
We would say region 1 is populated by protons and neutrons, the third option.
That is correct. Okay, we know that region 2 is only electrons, right? Because electrons are orbiting the nucleus, or it forms a cloud around the nucleus. Okay. Which of the three major subatomic particles has or have a charge of -1? One or electron, I, protons, I, neutrons. So what do you guys think?
I know
Which
electron.
the electron?
Yeah,
Okay.
because I know proton's positive and neutron's neutral.
That's right. So only one.
Look
Only
at
I.
me on fire.
Just a question.
Yep.
Maybe this is not important, but electron is -1. So is proton
Yes.
exactly equal to +1 or is it just approximately equal to +1?
No, it's exactly equal to +1.
Okay. So they both have the same like attractive force?
Yeah.
Okay.
Now, if we talk about mass, that's going to be a little bit different, right? Because neutrons and protons, technically, they approximately weigh the same. But actually, the neutron is a little bit more dense than the proton, but just by a little. Okay, 22. One of the features of Dalton's atomic theory, no longer considered to be correct, is all atoms of each element is identical in every respect. Which of the following statement which of the following statement is the best explanation of why this feature is no longer considered valid? A, the existence of isotopes. B, the existence of ions. C, natural variation in the mass of the proton. D, natural variation in the mass of the neutron. E, natural variation in the masses of protons and the neutron.
It's got to be the existence of isotopes.
That is correct. That is the correct one. Yeah.
Could there also be variation in the mass of a proton? Because
No.
protons are also made out of subatomic particles, right?
That is true.
So there could be some more in one proton than another.
So you're saying there's the isotope of a proton?
I don't know much about physics in that department.
Yeah. Well, at that point, so there is that possibility, yes, but it hasn't been proven yet. But we know the existence of an isotope would be the more correct answer because the other part has not been proven yet. So we don't know if all of the subatomic particles that make up a proton have the exact weight or they have different weights. So we don't know.
Okay.
That's for a physics class. Okay, but good thinking though. I like the thought process. So which of the following is an incorrect statement about Rutherford scattering experiment? A, most of the alpha particles directed at the thin gold foil passes right through the foil, undeflected from the straight line path. B, as a result of the experiment, the atom is depicted as consisting mostly of open space. C, a few alpha particles that were on a collision course with the gold electrons were repelled backwards at an acute angle. D, the experiment led to the conclusion that the nucleus of an atom contains all of the atom's positive charge. E, the experiment provided a partial understanding of the location and charge of particles within the atoms.
So I think it's due to it's because of the angles. I think were wide angles, not acute angles, but I don't remember 100%. So it would be I would think option C.
C, okay.
Yeah.
Okay, so that is correct. Option C. So all the other ones are correct. Option C was the one that would be incorrect. So. Okay, number 24. The nuclear symbol of the isotope potassium is 4119K. Indicate the number of protons, number of neutrons, the atomic number, and the mass number of the isotope. Okay, So number of protons first. So based upon that nuclear symbol, how many protons do we have? Can you guys see this?
Protons is 19.
19.
Okay. 19. Okay, so that means that we can get rid of this one. We can get rid of that one, and we can get rid of that one. Okay, so we have two possibilities now. So the number of neutrons,
We could jump to the mass number because that's displayed.
okay, so that's displayed at the top. So then that means that the first one is correct, and that one's wrong. So we know that the number of neutrons is just going to be the mass number subtracted the number of protons. So if you just subtract these two numbers, that's going to give us our number of neutrons, which I believe is 22. And then the atomic number is going to be the same as the number of protons, which is going to be 19. Okay, ready for the next one? Number 25. What is the name of the compound Hg2Cl2 and Zn3PO4 2? It was bad because I had to keep myself from saying the name.
Mercury is a 2 charge. Is it or not? Confused. Guess we
Well,
can
let's
jump.
find the charges first.
Okay.
We could jump to zinc.
So what would be the charge on each of the mercuries?
It would be a
Looks
2
like
because
one.
there's a wait. No, I think 1, huh?
That's right. So
That
this
caught me.
would be mercury 1, but we know we have to write it as a diatomic. So it has to be written like this. That means each mercury has a +1 charge. Okay, so that means that we can get rid of the first 3 answers. Okay, because we know that we're working with mercury 1. Okay. So we know it's mercury 1 chloride. And then what about the next one?
Phosphate has 3 minus, and we're using 2 of them, so that's 6 minus.
Okay. And so that means that we have zinc.
Zinc 2.
Okay. And when zinc is 2, do we have to say the Roman numeral?
I believe so, yes.
Actually, no. So zinc
No.
is one of those exceptions, like silver. So zinc is always +2, unless they tell you otherwise. And it takes a lot to make it anything else. So the correct answer would be here.
I hate those exceptions.
Yes, we have those exceptions. Okay, you guys ready for the next one? Gypsum or calcium sulfate dihydrate is shown in the image. What would be the formula for the anhydrous form of the compound produced when it is strongly heated? A, CaSO4 dot 2H2O. B, CaSO4 dot H2O. C, CaS dot 2H2O. D, CaS. E, CaSO4. What do you guys think?
Well, we definitely don't multiply it by a water molecule.
Mm.
Yeah,
Why
because
is
the
it?
water's gone
Because
Because
the
then
water,
it's hydrous.
because of the heat.
that's
yeah.
right,
Hydrate, yeah.
anhydrous, that is correct. So you have two choices. Sulfate. Calcium sulfate.
It's gotta be the last option.
That is correct, because we know that sulfate is SO4. Sulfide is just S. So
So if
anytime,
it's
go ahead.
so if it's a plus H2O, it's still anhydrous because it's not connected together.
Yeah, if it's a plus and H2O, that technically, it wouldn't be how you'd write the chemical formula, right? That would be the products. If they asked you what the products would, they could say plus H2O.
Oh, right.
Okay. Okay, next question. Which of the following formula name pairs is/are correct? So we have Galadium chloride. We have hydrogen, hydrosulfuric acid. We have, or HS, hydrosulfuric acid. We have PbNO2, parentheses 2, lead 2 nitrate. And we have NaClO2, sodium chlorate. We have K3PO4, potassium phosphate. So your choices are, they're all correct. I, and V are correct. V only is correct. I, and IV are correct, or none are correct.
I know 3 is wrong because nitrate is NO3.
Okay, so we know that one's wrong. So we'll put a, okay. Anyone else know anything else that's wrong?
Well, the first one is wrong because it's an ionic bond, and they didn't put the Roman numeral, and gallium is not one of those exceptions.
That is correct. Anything else wrong? What is the charge on sulfur when it's an ion?
Chloride doesn't look right either.
Okay,
CiO3.
okay, so that one's wrong.
The phosphate.
Sulfur's got a 2 minus charge.
Okay, so then how many H pluses should I have?
It should be 2, so this is wrong.
Okay, so then is potassium phosphate correct?
Looks like it. It's just 5.
Okay,
But why is gallium chloride incorrect? It's
It's
because
supposed to be with
there's a Roman numeral.
no Roman numeral.
I
Because
thought it was I thought it was only transition metals that get Roman numerals though.
transition metals,
Yeah.
post-transition metals, lanthanoids, and actinoids, and sometimes metalloids.
Oh, so it's just not transition metals.
Yeah. So any of them, anything that's in that middle, right? So these guys here, right? Except for the ones that are exceptions, these guys down here, right, are post. These guys, these are called post-transition metals, right? And then some of these guys when they act as metals. Okay, they're metalloids when they act as metals. So those should have Roman numerals, except for the exceptions. Okay. Let's see. Is that the right one? Yeah. 28. Which of the following name formula pairs is/are correct? We have HSeO3 minus hydrogen selenite ion. We have HSO4 minus hydrogen sulfite ion. We have H2PO4 minus bihydrogen phosphate ion. We have HCO3 hydrogen carbonate ion.
All right, number 3 is wrong because it's not bi, it's a
Okay.
di.
The second one is wrong because sulfite should have 3 oxygens.
Okay.
Let me just look at carbonate real quick. Carbonate.
That one looks
There's
good.
an-
I think
there's
both of
an
them look
H.
good.
Okay. So actually, both of those are correct. So that would be number, or the last one, E. So it would be I and I. Okay.
Because hydrogen selenide is going to have the same amount of oxygen and charge as hydrogen
right.
sulfate ion.
That is correct.
I mean sulfite. Yeah.
Okay. Well, another empirical formula one. Okay, it says a compound analyzed as 18.0% carbon, 2.26% hydrogen, and 79.9% chlorine. Calculate the empirical formula of the compound.
Well, we can assume 100 grams and then
Okay.
just divide everything by 100 grams.
Okay, so we have 18.0 grams of carbon. We have 2.26 grams of hydrogen. And we have 79.7 grams of chlorine. Molar mass of carbon,
12.
12. So we're going to divide it by 12 grams per 1 mole.
This should be 1.5. Yeah, 1.5.
Okay. Okay. The molar mass of hydrogen.
Guess we can put 1.
Okay. 1 gram. Okay. The molar mass of chlorine,
35.45. This should be 22.48. But with SIGFIZ, we can just do 22.5.
okay, so then what's next?
We divide by the smallest number, which is 1.5.
Okay, so since we had a 1.5 here, what are we gonna have to do?
Double it.
Double it, that's right. So we gotta double everything, so we multiply everything by 2. So do this times 2.
So that's C2H3Cl3.
C2, H3, Cl3.
Wait, why do we double it again?
So you double it because you ended up with 1.5. So if this guy number is, if your other numbers, so you're always gonna get your 1, right? If your other numbers are like 1.8 or 1.75, so then you're gonna have to find a number to multiply it by to make it close to a whole number. If it's 1.9, that's close enough to a whole number that it's okay. But if it's like 1.8, if it's anywhere from the 0.8 down to like 0.2, right? Then you're gonna have to find a number to multiply it by. And the rule is, so if it's 0.2, if it ends with 0.2, you're gonna multiply that by 5. If it ends with 0.25, what are you gonna multiply that by to make it a whole number?
4.
4. If it ends in 0.33,
It's 3.
it's 3. Yep, you're gonna multiply it by 3. Oops. If it ends in 0.5,
That's
like
2.
that's 2. If it ends in 0.67, that's gonna be multiplied by 3. If it ends in 0.75,
It could be 4.
And then if it ends in 0.8.
That's 5.
That's right. Okay, so after you divide it, then you end up with like 1.8. Then you're going to multiply it by 5. Because you have to have whole numbers, and like 1.5, that isn't close enough to a whole number so that you can round up. Does that make sense, Josh?
Yeah.
Okay, so let's see about this next one, see if it works out perfectly. Okay, so we have 66.7. So we're going to do it the same way. Make it grams. Carbon. We have 3.74 grams of hydrogen. And then we have 29.6 grams of oxygen. Okay, so for our carbon, we know carbon weighs how much again? What is the molar mass or atomic mass of carbon?
12.
12. Okay. Okay, we know that molar mass of hydrogen is going to be 1. And then the molar mass of oxygen is 16. That's 1 point. Okay, so we're going to divide everything by what number?
So 1.85.
Okay. Okay, so we have C3, H2.
H2.
Oh,
It would be A.
okay. Okay, questions? No questions? Any concerns? Okay. I'm gonna scroll down and see how many more we have here. Oh, we got a ways. We didn't even make it halfway. Almost. No, but they get easier, it looks like.
We're on 31.
Okay, 31. It says, which of the following statements is/are correct? The molar mass of carbon 12 is exactly 12. The phrase molar mass of chlorine is ambiguous. 3, the molar mass of a substance is the mass in grams of 6.02 times 10 to the 23rd particles of that substance. Or for atoms, the molar mass is numerically equivalent to its atomic mass. 5, the molar masses of elements are always greater numerically than the atomic masses of those elements.
I know the third one's wrong.
Okay. Are you sure?
Let me read that again. Molar mass. Okay, I'm kind of lost now.
That one should be correct.
Yes, that one is the correct. So the molar mass of a substance is the mass in grams of 6.022. So yes, so 1 mole is always going to be 6.022 times 10 to the 23rd. So the mass is going to be that. The molar mass is
Oh,
going to
so it's
yeah.
just C because that's their option. Three's in there.
What was that? Okay. So C is correct. Okay. And then what about 1? Is 1 correct?
Yes.
Yes. Okay. What about 3? I mean, 3 is correct. Okay. What about 2?
Oh
Incorrect.
no.
Although,
This is on my
I
table
mean,
35.45, so I don't know.
Is it ambiguous?
Oh no, it's 4 digits.
wouldn't it depend on the isotopes involved?
Would it depend on the isotopes that's involved? Well, but those isotopes are going to be pretty much uniformly because it's based upon percentages. So not really.
But if you got one that's like not like a natural sample, like an
Yeah,
artificial
but if
sample.
it's not naturally occurring, it's not going to count towards that because we only take into account the naturally occurring.
No, I get it. It's just
Yeah.
like an exception,
You're just
possibly.
trying to make it ambiguous. That's what you're trying to do. Come on, don't make it any harder than what it needs to be. Okay, what about number 4? Is number 4 correct?
Yeah.
If the
Yeah.
isotopes are, the same as the ones used to calculate the molar mass.
Okay, what about number 5?
No.
Okay, number 5 is incorrect. So that one's incorrect, that one's incorrect. So the answer should include 1, 3, and 4. Okay,
Agreed.
okay, good. Ready for the next one?
Is that one
Yeah.
just a repeat?
We've already done that one.
Yeah, it's a repeat.
I must have duplicated it. Sorry about that. Okay. A chemical equation may sometimes be balanced with a fraction coefficient. This is not appropriate when utilizing what interpretation of the reaction? A, macroscopic, B, molar, C, particulate, D, both macroscopic and molar, E, molar and particulate.
That's gonna be particulate.
That is correct.
Although, what does macroscopic even mean in this instance? Because that's not a quantity exactly.
No, not really, but you're saying you have enough that you can actually visualize it. So are you going to be using your moles or are you going to be using,
Your eyes. Yeah.
Yeah, yeah. Okay, balance. So we need to balance this chemical equation. So what is the coefficient for H2 when the equation Ba plus H3 ASO4 yields H2 plus Ba3 ASO4 2? Is balanced or is properly balanced? Okay, how many BAs do we need? So we got three
Three.
here, got one there, we need three. Okay, how many? So H's, we have 3 and we have 2. And then ASO4. How many ASO4s do we have?
One on our left and two on the right.
Okay, so we have 2 and you said 1. Okay, so what do I need to do? So if I put a 2 here, that'll give me a total of 6 hydrogens. So then I'll need to put what in front of here to balance it out?
A 3.
And then that would give me my 6. Okay, so then everything else balanced. So what is that? 3. And that would give me 2. Okay, so then what is the coefficient in front of H2?
3.
Okay. Number 35. Calcium hydroxide is added to perchloric acid. Write the balanced chemical equation for this reaction. What is the coefficient for perchloric acid? Okay, so calcium hydroxide. Start off with that. Symbol for calcium?
Ca.
The ion, Ca.
Mhm.
And OH for
And
hydroxide.
Okay, how many OHs am I going to need? What is the charge?
2.
I'm going to need 2.
Two.
That's right. Because we know that calcium has a +2 charge. And then perchloric acid. Per means what?
Less, like less than, oh no, wait.
That's extra.
Extra, yeah, extra.
Okay, that's right. It's extra.
Hypo is lower, right?
That's right. So we need 4 oxygens, Cl, and then how many H's do we need to balance out that charge? What is going to be the charge on the perchlorate ion?
Or you need an H.
I need just 1 H. That's right. Because H plus will balance it out. Okay, and then that's going to yield. So basically now we're going to have
That's an acid base, so a salt and water.
so we're going to get salt and water. That's right. So we're going to have H2O plus calcium perchlorate. And how many of them do we need to balance out our calcium?
Let me find it.
2 calciums? This is chlorate?
How many chlorates do we need to balance out calcium?
Yeah, 2.
Two.
Okay, we're gonna need 2 because chlorate is a -1 charge. Calcium is a +2 charge, so we're gonna need 2. That's right. Okay, is it balanced? How many chlorates do we have? Start off with that. Or I'm sorry, how many perchlorates do we have? On our, that's an H. On our reactant side,
1,
1. Okay, on our product side,
2.
okay. Okay, so if I wanted to balance those, I need to do what?
Make the coefficient 2.
Okay, so then that gives me now 2. And then that gives me 2 hydrogens over here. And if we look at this guy is just, it's the same thing as saying HOH. We have 2 OHs over here. We have 1 over here. And right now we have 1 H. That looks horrible. My 3rd grade handwriting is really struggling today. Let's see, H, OH. So that's just water, right? So then one. Okay, so then how many waters am I gonna need so that I would end up with 2 H's and 2 OHs? Right now I have 1 and 1.
We need a 2 for
Okay,
the
so
H2O.
that's right. Okay, so then that would give me my 2. And now I have a balanced chemical equation.
Wait, isn't H2 by 2 4?
What was that?
Because
Oh,
H
sorry.
on the
It's,
right.
you're right. That's, no. So it's H. So we have 2 H's. So technically, if we do it like this, right? So we have 2 H's and we have 2 OH's. So that's why we have 2 and 2.
Oh, okay. I'm just messing you up.
Yes. Okay. So then that means our coefficient that's going to be in front of the perchlorate, perchloric acid, sorry, is what? Coefficient. Right here, 2. So we have a 2, coefficient of 2 in front of it. Okay, number 36. It says, consider the following particulate level representation. The larger spheres represent nitrogen, the smaller spheres represent hydrogen. Which of the following correctly characterizes the representation? A, the reactant could be represented as NH3. B, the products of the reactions are N2 and H2. C, the equation is balanced. D, if the reactants were written as shown above, the coefficient for nitrogen containing product would be 4. E, all of these correctly characterize this reaction?
That'll look correct so far. I mean, it's balanced.
Okay.
The reactant could be definitely NH3.
Mm-hmm.
So if there's like two right, I mean, you can't just pick one. So I think it's all.
Okay, that is correct. The last one is correct. It's all. Okay. Lead 2 carbonate decomposes to lead 2 oxide and carbon dioxide. Write the balanced chemical equation for this reaction. What is the coefficient for the lead 2 carbonate? So that means lead 2 means it has what charge associated with it?
I think
2 minus.
2 plus
Minus.
Two
lead.
plus.
Isn't lead have only a 2
Oh,
plus?
Lead's
yeah.
in the middle, no?
Okay. And then carbonate has what charge associated with it?
2 minus. So CO3, 2
minus.
minus.
That's all right. That's right. CO3, 2 minus. So then they balance each other out perfectly. So we can just put them together. So we have PB, CO3, and it's decomposing. And it makes PB, how many oxygens do I need to balance it out? Since it's lead 2,
Just one.
I'll just need 1 plus carbon dioxide.
CO2.
Okay. Is it balanced?
Yeah.
Yeah. Okay. So then what is the coefficient in front of the lead 2 carbonate?
Looks like 1. Because
That
it's
is
there.
correct. Yeah, that is correct. Okay. Consider a solution in which the solute exists only as the molecule shown below. Which of the following describes this solute? Okay. A, non-electrolytic. B, strong electrolytic. C, weak electrolytic. D, ionic. That is a horrible looking figure.
Can you go over what an electrolyte is?
An electrolyte is something that would be broken up in solution. So they're telling us that this is a solution, right? So, and then you have only the solute that's existing in the solution, right? So what you're seeing is the solute itself.
Wait, so electrolytes are things that are able to like break down?
Yeah, so electrolytes will break down into its ionic components. So
Mhm.
it'll be charged. So you'd have charged components. And you break down, dissolve.
Well, these are still together, so
Yeah, so
non-electrolyte.
So this would be a non-electrolyte. That is correct. Okay, in 39, it says, in the balanced net ionic equation for the reaction of solid calcium carbonate and aqueous hydrochloric acid, which produces aqueous chloride and an acid that is decomposed into two other products. What appears on the left-hand side of the net ionic equation?
Well, one of our reactants is CaCO3 solid. So that's gonna be on the left
Okay.
side.
Okay, so then that means we can get rid of this guy. And we can get rid of this guy. So we have three choices now. Hydrochloric acid. What is hydrochloric acid?
It's HCl,
Okay.
but since it's in a solution,
Mhm.
it's gonna be aqueous, so they're split apart.
Okay. So then we can get rid of this guy because there's no H, and we can get rid of this guy because there's no Cl. So our correct answer is A. Okay. Everybody good on that?
Yes.
So why don't they have it
Number-
HCl aqueous right there? Like together.
Because they told us they're talking about the net ionic, right?
Oh, I didn't see that.
Because then they want it broken up into the parts. And then we also know that the calcium carbonate was a solid, so. Okay, number 40. These are going to probably be the last 4 or 5 questions that we're going to go through because I need to try to get home at some point tonight. Let's see. The net ionic equation for the reaction between copper and silver acetate. The apparatus for the reaction is shown below. Regarding all the salts containing acetate ions as soluble in water, copper is above silver in the activity series. What will appear on the product side of the balanced net ionic equation? Now we're talking about net ionic equation.
So copper is gonna replace silver in that AgC2H3O2.
Okay.
So, so the silver is gonna be by itself, essentially.
Okay. So we're gonna have silver by itself. So that's silver by itself. And that means that all of these other guys are gonna be gone, right? Because they're not ions, right? It's gonna be the full silver. So that is correct. Question 41. So which of the following, so I'm sorry, it says, which of the following combinations of reactant does not produce a net charge as shown by the net ionic equation? which of the following combinations of reactions does not produce a net change? Sorry, I'm sorry, a net change, not charge, as shown by the net ionic equation.
Would we use like the activity series sheet to figure this out?
No, you'd probably
No.
use another one. Yeah, but you're gonna use a sheet from your packet, that's
Oh, the
true.
solubility chart.
Solubility, okay? So we're looking for something that we only end up with total ions, right? So all spectators. So which one of these will produce all spectators? Well, we know that this is an acid-base reaction, so that one's out of the question. It's not going to produce all spectators because we're going to get water and something else. So that one. What about this one? Don't we know from the question above, calcium carbonate, doesn't that form a solid?
Yes.
Okay, so we can get rid of that one. What about when we have hydrogen and carbonate, that actually decomposes to water and, is it water and oxygen? No, it's carbon dioxide and water. It decomposes to carbon dioxide and water. So that one is also out of the question. And then when we have hydrogen and sulfite, it actually decomposes to SO2 and water. So that one. So if you guys look in your solubility table, if you look for ammonium, isn't it always soluble?
Yes.
And what about nitrate? Isn't that always soluble?
Yes.
So then we know that that is the correct answer. Okay.
Dr. Henry?
Yep.
Wait, how do we know it doesn't become a solid on the activity series?
And not from the activity series, from the solubility table. Let me pull up the solubility table. Sorry. Okay, so let's keep moving forward then. So you're going to look at the solubility table. It's in the back of your chemical packet. And then you'll know that the nitrate and the ammonium, they all, whatever they bind with, they will never form a precipitant. They're always going to be soluble. Okay, so what ions are present in the ratio? Let's see, what ions are present in what ratio in a solution of aqueous ammonium sulfate?
Well, it says it's soluble,
Uh-huh,
so I guess we have to look at the aqueous symbol, which is on all of them.
that's right. But it should be, is it gonna be this? The first one?
Eh,
Now what happens? Soon as it separates, they're free.
it all breaks up.
It breaks up. So then it's not going to be written as this. So it's never going to have the subscript. So that's wrong. So anything that has that subscript is going to be incorrect. So then what about this guy?
As a subscript.
But it
Right.
has,
No.
it normally has its subscript, right? Because it's ammonium, right? Okay, so
But
that
shouldn't it break up?
It did break up, so that's why we have two, right?
Okay.
Okay, so because there's two here, now they're separate. So this actually would be the correct answer. This would be incorrect because of the charge, right? On the sulfate, it doesn't have a two charge. And this would be incorrect because it doesn't dissolve, it doesn't break down into just nitrogen ions and hydrogen ions. Does that make sense?
Yeah. So solubles that are soluble don't break down further than necessary.
That's
So
right.
you're basically just like working backwards. So instead of like looking for the product, you're looking for the reactants, kind of.
Sort of, yeah.
Yeah.
Yeah. And remember, it's an ionic, polyatomic ions, they're ions, so they're charges. So you want to keep them together, so they're polyatomic. Okay, 43. So which of the following is / are the major flaws of the Bohr model of hydrogen? Excuse me. Hydrogen is the only atom that fits the model. 2, circulating orbits violate the law of conservation of energy. 3, it explains the atomic line spectra in terms of the electron energy. 4, it introduced the idea of quantized electron energy levels in the atom.
Are 1 and 2 the major flaws?
That would be correct. Okay, so
Although I'm a little confused about circular orbits violating the law of conservation of energy.
because when we talk about, well, one thing that we know that it isn't true, right? Because we know that we have electrons that are sitting in the same orbit and it's not all circular. There are different shapes, and those different shapes also represents an energy state. And so otherwise, like mathematically, it would violate that energy level. So energy would not be conserved because you wouldn't be able to maintain a state where you have an electron going in one spin and another electron going in another spin within the same orbital. Does that make sense? So like,
I think I'm getting it, but I know about the s orbital and the px, py,
yes,
pz.
that's right. That's right. Okay. And so, but if they're just all circling around the nucleus, right? So that's going to violate our energy because at some point you may get the two electrons in a good proximity to each other, and that's going to cause repulsion. And so then that would violate, that's going to cause more energy than what you're supposed to have.
Okay,
You're not going to
yeah.
be able to conserve. Number 44. What is the ground state electron configuration for potassium? Okay. So if we go up here, potassium is located here. So what would be the core noble gas? For
Argon.
potassium,
Argon.
argon. Okay. Okay. And then it would be, here's potassium. We're in what period?
In the fourth period.
This would
It
represent
should be
an S. That's right.
yeah.
And there's only one electron that's going to be there since we're at that first spot. Okay, so it should be AR for S1. Okay. Okay, number 45. The atomic size varies with the position in the periodic table primarily because of what influences. I, the highest occupied principal energy level. So in other words, our periods. I, increasing number of electrons with increasing atomic number. I, nuclear charge. So you have only I, only I, or you have I and I, or all three. What do you guys think? Talking about atomic size. Does it get bigger as we go down
Yes.
the periodic table? So then that means that this one is right. Okay. What about that is also increasing our number of electrons, isn't it, as we go down?
Yeah.
Okay.
Yes.
Is it also increasing our atomic number?
Yes.
Yeah.
Is our nuclear charge increasing as well?
No.
Nuclear charge is not increasing?
Wait, what is
Yeah.
nuclear charge again?
It's
Nuclear
from the
charge is
top right, and then it goes.
nuclear charge is just also the number of protons, right? Because we're looking at just the nucleus. So is the number of protons increasing?
Yeah.
Yes.
Okay. So
I
then,
was thinking of something else then.
I thought it was the charge of the what was it called? Like the changing of electrons, like that charge, the negative charge, positive charge.
oh, ions.
Yeah.
Your ionic charge. So no, we're just talking about the nuclears. So you're talking about how many pluses you have in there. The more pluses you have, it pulls the electrons closer to it, right? So that's the reason why as we move across the periodic table, it gets smaller.
So are like the protons and neutrons what like change the elements?
It doesn't change the elements. The only thing, the element is going to be the same. It's always based upon the protons, right? But what we're saying is that it'll change the size. So for instance, if I have sodium and I have sodium plus. Okay, so because sodium, if we take a look at sodium, it has a total of 11 protons, right? So, and then sodium plus has 11 protons. So they're both sodium. Now the difference is that the sodium plus is going to be smaller because the electrons get pulled tighter because you have a stronger nuclear charge than you have with the electrons on the outside. Does that make sense?
Yeah, because it has that positive charge.
That's right.
So
So it's
the
going to,
electron changes it a little bit.
that's right. The loss of the electron changes it. It makes it smaller because you have less electrons and it's going to be pulling all the electrons tighter because it's going to have a stronger pull.
Kind of scared. The final has 46 questions, and that's like 200 points.
So
Yeah.
helium is the smallest and then francium is the biggest?
Yes.
Okay.
Now, there are exceptions.
Oh no.
So as you go across, typically, it gets smaller, but you'll have a little blurbs. Nitrogen is one of those blurbs. For some reason, nitrogen is actually, I believe it's a little bit bigger right, a little bit smaller than oxygen, where you'd expect oxygen to be a little bit smaller. And then I think beryllium does the same thing as well. But there are just a few exceptions. But for the most part, it obeys the rule for the most part. Okay, so which of the following is the letter representation of the electron orbital below?
PZ.
Okay. Do you guys all agree?
Agree.
That is correct, because it's on the z-axis, so it's the P. Looks like a yeast cell. So oops. Number 47. Identify the statement among the following that combines a correct cause with a correct effect of that cause. A, sulfur atoms are smaller than phosphorus atoms because sulfur has a smaller atomic number. Is that true?
No.
Incorrect.
That is incorrect. The radius of calcium atoms are greater than the radius of magnesium atoms because the ground state electrons occupy a higher level in calcium than in magnesium.
That sounds correct.
Okay. So that one looks like it's correct. So we'll just read the other ones just to go for kicks and giggles. The atomic size increases from left to right on the periodic table because the density increases in the same direction.
No,
No.
because this one's like right to left for density.
Yeah. The relative size of silicon atom and aluminum atoms are not predictable based upon the nuclear charge and the highest occupied energy level because one factor predicts silicon atoms to be greater or to be larger, and the other factor predicts aluminum atoms to be larger.
That's a lot of words.
It's also BS, right? So that one is
Yeah,
not.
big answer.
Okay, so more than one question. Okay, so the correct answer is the second one. Okay. So which of these ions has a Lewis symbol of the following form? N 3 minus, F plus, C4 plus, argon, O2 2 minus. What do you guys think? First off, what does it say?
J's
Ions.
ions.
Okay, so is there something on here that isn't an ion?
Argon.
Argon, okay. The next thing is how many,
Valence
elements.
electrons.
What was that?
Wasn't it valence electrons or no?
Yeah,
It,
it has 8 valence
it has
electrons.
it has 8 electrons, right? So is it also monoatomic or is it diatomic? What's being shown?
Looks like mono.
Okay, so then we can get rid of this one. Okay, if fluorine loses an electron, how many valence electrons would it have?
If it loses, it would have 6.
It would
6.
have 6. There's 8 around here, so we can get rid of that one. If carbon loses 4 electrons, how many valence electrons would be left?
None.
None.
No, it's got two, doesn't it?
No, we're using the the element periodic table? It's like 1,
Oh
2, and
shoot,
then
yeah.
13,
One,
14.
two, three.
So we're just taking so we're
Mhm.
pretty much ignoring the 3D.
Okay,
No, I thought the carbon's gaining valence electrons because it's 4 minus.
Oh, it's
it's
4
right
plus.
here, it's 4 plus.
Oh, I can't
The
see it.
plus means you're losing.
Yeah,
Yeah, I couldn't see that. That's why.
okay.
Okay.
So then the correct answer is,
And 3 minus.
okay,
We're gonna end on that or
what was that?
are we ending on that? We're doing one more.
We're good, we'll make it to 50 and then we'll stop at 50. Okay? Okay, so given the following, what time is it? Oh yeah, we should probably end right now. Given the following electronegativities, and you guys see them there, arrange the bond according to the decreasing polarity. So we want decreasing polarity. So we're going from the highest to the lowest. Okay, so we know when we do this, we're just taking the difference between the two. So let's start off with, we'll put them in order. So we'll go C minus N, or N minus C. So then that's going to be 3.0 minus 2.5. So that's going to give us 0.5. Then we have a bond C. Oh, we know CC is going to be 0. Okay, then we're going to have CO. And that's going to be 3.5 minus 2.5. Oops, sorry. I said one thing and I wrote a totally different thing. Yeah. So that's going to be 1.0. And then we have CF, which is going to be 4.0 minus 2.5. And that's going to be 1.5. So the 1.5 is a larger value, so you're going to have more polarity there. So it's going to go CF first. So then we can get rid of this one. We can get rid of that one and that one. Then it's going to go the CO. So then we can get rid of that one. So our correct answer is going to be C.
All right, for 50, I know this one. I know this.
You know this? Okay,
Yeah.
50 for the goal. What is it?
It should be 5.
Okay, 5. A noble gas. Okay. Do you guys agree? It says considering the following periodic table, in which of the numbered sections will the element form an anions that are isoelectronic to the noble gases? And that would be all of our non-metals except for the noble gases. So that is correct.
Go to
Okay.
bed.
And then would like one be like cations, but they're also like isoelectronic to noble gases.
That's right.
Okay.
Yep. And 2, those vary, right? 2 and 3s. 2, 3s, and 4s when they form cations. So they're all going to vary. Okay. Okay. Good luck. Study hard. Any questions?
Wait, how many questions are gonna be on this final?
Let me check. It says 46.
And it's going to be covering all your chapters. You're going to have, but the larger portion of it is gonna be what we did in the very beginning. So if you have a good grasp on that, you're gonna do pretty good.
Wait, the stuff from the beginning, like the very beginning?
Not so it's covering everything that you've learned throughout the
Mhm.
semester, right? So this is stuff from the very beginning that you just
Oh.
did, right?
Yeah.
And so you've covered everything, right? But it's all built on itself. But we've talked about these last couple of weeks is going to be primarily on there. It's going to be more of that stuff than other things, and they're going to be weighed heavier.
So is that why you did presentations? So it could be a little quick rundown.
Pardon me one more time.
Is that why we did presentations on the topics for a quick rundown?
Yes.
Okay.